please.
No. She dyed it ever so slightly every time, so you wouldn't really notice her. That's all. It got steadily.
Okay. I want you to find the limit as x approaches 3. Jeez. X squared minus 9 over x minus 3. Why are you looking at it?
I don't know. Why does that mean?
Just trying to figure out why you're looking at me. And then it's creating like this vicious cycle. Remember, the limit part is supposed to stay. If you're showing your word, the limit part stays there until you plug in the number. So if you're doing this on multiple choice, it doesn't matter at all. But if you're in a free response, you need to keep that limit as x approaches 3 there until you start plugging in numbers. And then you can say, okay, 3 plus 3 equals 6. So that was like educational right there?
Yeah.
It wasn't meant to be. It was meant to be reviewed.
Yeah.
How long was Christmas break?
It's like that thing where you learn so much past this point that you're back to it just doing
Yeah, wasn't this like
Yeah. This is probably like third day, yeah.
Okay. That's why I don't remember it.
Stop talking!
Yes, sir.
Wasn't really either. Alright, let's say I'm gonna try to squeeze one in over here. Limit of x squared minus 2x minus 15 as x approaches 3. No, that doesn't work. Hold on. X approaches 5. Or x squared minus 25. So do that one. Your midterm / the recovery for your last test. Let me talk about that for a second. So we've done, I can't even remember exactly, but I think 3 different assessments on applications of derivatives. Or let's just say derivatives, maybe 4. The midterm is going to cover all the derivative stuff that we have done for the whole year. So basically your midterm is everything except for limits. But, so that's bad news, I guess. Good news is if you do better on the midterm than any one of the tests we had during that time, I'll replace that test with your midterm rating.
Just one test?
One test. I'll replace your lows, and I'll replace them all. So, you're getting a little bit greedy.
No, I
So,
knew what you meant.
So if you got an 80, 75, a 40, and a 90, those are your 4 test grades since we've started derivatives. So limits are not in this game at all. But those are your, I don't even know if it's 4 tests, really. But let's say there's 4 tests, and then on the midterm, you get a 70. That 70 will actually count twice. It's going to stick there in the midterm, but I'm also going to cross off that 40 and make it a 7. So that's basically saying to me, if you can prove to me that you know it by now, then I'll go back and be like, okay, yeah, you've learned it, so I'll fix your grade back here too. So it is very nice.
I can give you a bug right now.
Well, the point is to motivate you to study. Like,
That's a good motivation.
that's what I'm going with. Okay, this one here. This would be the limit as x approaches 5, x minus 5, x plus 3, x plus 5, x minus 5. So then it's the limit as x approaches 5, x plus 3 over x plus 5. And now we're plugging in a number so we can actually get rid of the limit and say, okay, there's our answer. How many out of 8 tenths there? Or 4 fifths if you reduce it. Oh, yeah, that's supposed to be. That was pretty common. Questions on just like reviewing that stuff? Let's say, instead of doing what we did, we took the derivative of the top and the bottom. What's the derivative of x squared minus 9? What's the derivative of x minus 3 on the bottom? Plug in 3 now.
Oh my god.
What are you going to get?
Why did you use that early?
You didn't know how to take derivatives.
Why did you just take derivatives like that your first day of school?
Because you need to learn limits. See how this is just going to be a circle that keeps going. Oh. Over here. What's the derivative of the top? 2x plus minus 2. It works, yes. Right. What's the derivative of the bottom? 2x. Plug in 5. What do you get?
That's beautiful.
You get 8 over 10, right?
I think I can try.
Right?
Wow.
Wow.
So this is what's called LHopital's rule. LHopital.
Oh, that's not LHospital.
Hospital's rule.
Well, it would be
Standard
hospital.
I put it as
You're a little dyslexic there.
In his defense, I also read it as hospital.
I put it as hospital. Speaking Spanish.
Casey's not just like Casey's very
I have just like sometimes.
That's LHopital's rule. I'm going to go through. These are kind of tough to make up, so I just printed off like extra ones on your worksheet. We'll start working through some together. Well, the rest of them will be here. So on a multiple choice, these are pretty simple. There's not too much to it. Take the derivative and plug in. On a free response, they are kind of a pain because you got to show them some pretty specific stuff. And last year was the first year that the AD test put this topic on there, and there was not a question on the test about it. So they said, this is the first year, this is fair game, and they didn't put a single question on it. So that tells me there is for damn sure going to be one. A free response, at least, this year. I think they were kind of like, here's the grace period, you're supposed to know this, but we're not putting it on there. But this year, I mean, I'm pretty surprised it wasn't a free response. So that's the rule. If the limit comes out to 0 over 0, or infinity over infinity, and it doesn't matter if it's positive or negative, both of those are what's called indeterminate. And that allows you to use LHopital's rule. You can't just use it whenever you want. You only use it if, when you plug in, you get 0 over 0, or some version of infinity over some version of infinity. But if you can use it, let me show you how to do it on like a free response. Are we done writing this? Okay. I'm going to start with number 2. Number 1 is a tougher one. So here's what you would have to do Well, let's do this. Don't write on here, because I want to show you like what you have to write out. Just on a separate sheet, or on your desk, or in your head, or whatever. What's the answer? Like, work out the answer. Just based on what you know so far, it's even good. I can't see. There's like a glare. I was trying to read whatever you got.
You're right.
One. The answer should be one. So let's go through how to do it, and then also like the steps you have to write out to show the AP graders. So if I plug in 0 on top, what's e to the 0? 1 minus 1. So I get 0 on top, right? What do I get on the bottom? So you're going to do this. Don't put an equal sign, because it's not true that that equals 0 over 0. It gives us 0 over 0. When it gives us 0 over 0, we know we're supposed to use LHopital's rule, so we write an LH there to let the people grading the test know that we know, okay, I got 0 over 0 I plugged in. I'm going to use LHopital's rule here. And then we're going to do it. But this, if you don't write this, you're missing points. So you got to show them. And this could be like infinity over infinity too. Depends on what form. But you're going, okay, 0 over 0, LHopital's rule. Now you got to write out kind of the definition of it and say, well, the limit as x approaches 0 of what you gave me is going to be equal to the limit as x approaches 0 of the derivatives of the top and the bottom. So what's the derivative of e to the 5x? 5x times 5, and then the minus 1 doesn't matter, right? Like when I take the derivative of the minus 1, it's just 0. What's the derivative of the bottom part of 5x? 5. So this is not quotient rule. We're not really taking the straight up derivative. We're just saying this rule says if we're looking for a limit, we got 0 over 0, we can take the derivative of the top and the bottom separately, not quotient. Plug in there. I think we should be okay. So plug 0 into the top now. Well, here, let's just do this. 5's go away. What's e to the 0? That's your answer. You got to show them this little arrow when you get when you plug in. You got to write down. You can write down LHopital's rule if you want, but you can just write LH and get away with that. Rewrite the original equation. Tell them what's equal to now, and then plug in. And sometimes you got to do it twice. Sometimes when you get to here. When you plug in, you'll get 0 over 0 again. Then you gotta like do the second derivative of the top and the bottom. It's just like repeat the process. You can do the rule infinite number of times if it works. If you need to. Let's jump to number 3. Because that's what we gotta do twice. I think. So plug in infinity. So what's e to the infinite power? Basically infinity, right? What's infinity squared? Basically infinity. So that's just like 0 over 0. That's indeterminate. We're going to write LH because now we're going to use LHopital's rule. LHopital's rule says the limit as x approaches infinity of what you gave me. So you have to write down that initial thing. Is going to be equal to the limit as x approaches infinity. Okay, now I'm going to take two separate derivatives. What's the derivative of e to the 2x? That's e to the 2x times 2, or 2e to the 2x. What's the derivative of the bottom? 2x. Plug in infinity now, what do you get? It happens again, doesn't it? So I get infinity over infinity again, so I'm going to write LH again. And now I have to do the rule again. So I'm writing down what I had, and I'm just like, try another level. Like, okay, that didn't work. Try one more level, maybe it will. So now, what's the derivative of 2e to the 2x? Wouldn't it be 2e to the 2x times 2? So 4e to the 2x? And what's on the bottom? 2. 4 over 2 goes away, right? So this becomes 2e to the 2 times infinity power. Remember, with infinity, you're looking, so highest power, horizontal asymptotes, that's actually what we're finding here. If your highest power is on the bottom, what's your limit going to be? If your highest power is on the bottom of your fraction, what's your limit? 0. If your highest powers are tied, what do? You take the coefficients. If the highest power is on top, it's either going to be positive or negative infinity. You just got to kind of work through and see what it is. So if I take e to a gigantic positive power, what do I get? I get a gigantic positive number, which is infinity. So that's what we had to do twice to get to what we're supposed to do. How's that seem? It's the what?
It's the Jersey
Jersey.
from 7th grade, where we spent like a week on this problem, and then realized that we could just use x plus b.
Oh my god, don't talk about that.
So it's like
Let's do it.
Some of
Guys.
you realized you can use an x plus b, because I teach integrated math now. There's a lot of people.
No, this
that
is
don't.
the 7th grade before we learned
This is like the 7th
Then at the
grade
end of this big giant project,
You guys are
just
really
like, yeah,
covering
here's
some
this
pain
thing
with
called
this.
x plus b.
So they wanted to like,
I failed the test.
like to try to figure it out on your own.
What's the
Rod
B
gives it-
thing
Rod-
you're talking about?
Rod gives extra credit.
But the point was to like get you to
Yeah.
like get your hands dirty and figure it out yourself, kind of.
It was like learning. It was like learning the next part. Yes, but we still have to do it.
Sometimes that's sometimes that's important, sometimes it's just not.
Yeah, and then we're sitting here 5 years later, still mad about it.
Like,
Yeah, you guys need to get over it.
yeah, it's like you're really harboring
Right.
something inside.
Let's look at one. I'm fairly certain you're gonna want me to do one. Let's do that.
Yeah, let's go for it.
So plug in. First of all, think about plugging in infinity to that. That's a little bit of a goofy situation, but what this would be is what's the natural log of infinity plus 1 to the 5th power? And so what that says is e to what power gives you this gigantic number? So what's the only power you can raise to get infinity? Infinity. So the top tells you infinity. The bottom is saying the same thing. E to what power gives me infinity to the 4th? So what do I raise e to get infinity? Is infinity. So now that we know it's infinity over infinity, what am I writing? I'm letting them know, okay, this is L'Hopital's rule. Now this one, the problem is the derivative. So first I'm writing down their version. Say, okay, I know that what you gave me, I can take the derivative and do it that way. But you got to start by saying, okay, here's what you gave me. Now, you got to remember the derivatives, like LN. So what's the derivative of LN of blah? It's 1 over blah times the derivative of blah.
Oh,
Right? The chain rule. So the derivative of ln of x plus 1 to the 5th is 1 over x plus 1 to the 5th times,
5
what's the derivative of x plus 1 to the 5th?
times.
5 times x plus 1 to the 4th. Oops, I forgot something here. I forgot my limit thing. Sorry. So this is just going to be a giant algebra problem. The calculus isn't the hard part. Like with a lot of things. On the bottom, what's the derivative of 1 of x? What's the derivative of ln x to the 4th? 1 over x to the 4th times 4x to the 3rd. So I got some simplifying to do here. I'm not plugging in a number yet, so my limit is still with me. You got to keep writing that limit every time. On top, I'm going to cut to that. You see what I did to get that? The 5 jumps on top. These 4 would jump on top, but 4 of them would cancel and leave it. That'll leave you with 1 of those x plus 1s on the bottom. Right? On the bottom, I'm going to have 4 over x. Agree with me there? 4x to the 3rd over x to the 4th, so you're left with 1x on the bottom after you cancel, and that 4 is on top. And then we do not divide fractions, right? We invert and multiply.
You still have to read all the limits.
I haven't plugged in yet, so that limit still has to be there. That's the worst part about these problems. You guys with me? Let me say it. I'm starting to feel like losing people. Alright?
No, you're good.
So then on top, this would be 5x. On the bottom, this would be 4 times x plus 1. So there's a lot going on here. We're getting back to limits, which we haven't done in forever. We're doing derivatives, which we haven't done in forever. Oh, that's not true. We're doing derivatives, which we've been doing for forever. Horizontal asymptotes we haven't done in a really long time. So now we got a limit at infinity. That means you're looking for the highest power. Where's the highest power?
They're tied. So
It's tied, right? So this would actually be like 4x if I distributed, right?
Yeah.
So 5x over 4x, so your answer is 5 over 4. Got it. This up here? So when I plug infinity, because your first thing you're trying to do when I see a limit problem is kind of just plug in and get an answer. So I put infinity in for that x. Then I'm saying, okay, the limit, I want the natural log of infinity plus 1 to the 5th power. So basically, I want the natural log of a gigantic number. The way natural log works, that means there's an e down here. E is like that 2.718 number. And then the question is, e to what power gives you this ginormous number? And the only thing that would do that is infinity. So the power that gets us this huge number is infinity. You're more used to seeing, like, let's say this, like log base 3 of 9. That would be 3 to what power gives me 9? So it'd be 2, right? It's the same idea, it's just now we're in infinity. So basically 3 to what power gives me, infinity. Alright? Yeah?
So at the very end, when you get your final answer, do you put an equal sign before it or an arrow? Because you got both.
Because now I know the
Okay. You don't want, like.
I put equals.
I thought I saw it. I thought you saw it. Put an arrow.
So now that I'm plugging in, like that's the answer. Those are equal. Any other questions, like in general, or on the first 3 at all? Maybe you could go with it. You want me to do 4? You want to try 4?
I like you doing something.
Try 4, and then I'm going to go minutes on it. I like people do stuff for me too. That's the it's like either what power you want. So what power always gives you 1?
0.
0 power. answer's right back. I was trying to like do it in my head. Guess I don't need to. Alright, so if I plug in 1, I'm going to get 0 over 0. So that's the first thing I'm doing. And I'm going, okay, that means, hey, I'm about to use LHopital's rule. And then, saying, alright, well, I know the limit as x approaches 1 of what you gave me is the same as the limit as x approaches 1 if I take the derivative of what you gave me on top and bottom. So this will become 5 here. This will become 1 over x. And now we've talked about, like, if you're just going to plug in, don't waste time simplifying. Like, there's no need to simplify this and get rid of the fraction over the fraction, because you can just plug in the number right now. So if I plug 1 in, what's 1 over 1 on the bottom? Yeah, this is the part I'm asking you what 1 divided by 1 is. I'm all scared at it. And then 5 divided by 1, so that's equals 5. If you wanted to simplify it, this would be like 5x over 1. Plug in from there. You don't have to. Stretch or question? Okay. Questions on? How many had that? How many got to it like you were good without me? I'm useless at this point.
Yeah, pretty much.
That's fine. I want to be useless. Means you guys know it. Alright, so the rest of it's your homework. So you got the rest of the time right now. The answers are online and they're worked out like the way they should be, so you can check them on Schoology. Then you gotta do twice. What's the derivative of cosine of 3x? Wait, plugging it originally? What are you talking about? You're thinking 0 over 0. Cosine of 0 is 1. Excellent. You're doing the side.
How was your Christmas break?
Well, so no, you put me in a spot here where I have to like ignore your question and be rude, or answer your question and distract people